Hello there, Transport 2A students. This is Mr. Jairam. I'm one of your lecturers. I'll be doing a lesson today on vertical alignment. So pay attention. I'll also upload the PDF format of this on Moodle so you can look at it on your own. But for now, I'm doing a video on the example. But before we go on, first of all, let's look here. This is a horizontal alignment here, okay, where if we zoom into it, this is looking at it from a plan view from the top. So imagine you are flying an aeroplane and looking at a road down below you. And you got the straights and the curves, straights, curves, and straights. So horizontal alignment is made of roads of straight lines that join to form PIs, and where the PIs meet we put a radius, and the beginning of the curve and end of the curve we mark it on, beginning of the curve and end of the curve we mark it on where the PIs are, and the radius is determined on the design speed of the road, so that vehicles traveling on this road do not have a sharp turn at a high speed. They can maneuver around the road quite comfortably. Okay, so that's a horizontal alignment, but this lesson is on vertical alignment. So if we look at vertical alignment, now your plane has crashed. You've been flying on a plane and it's crashed and you fell down, and with one eye you're looking at the road from the side. So now you've got gradients, or your road is climbing up hills or mountains, and then your road is descending, and your road is climbing up and descending. So that's called vertical alignment, where we got a series of inclines and declines, inclines and declines, and they're made up of straight lines called vertical PIs. So when a road inclines and then declines, and we put a curve on it, we call that a crest curve. And when a road declines and then inclines, and we put a curve on it like this, we call it a sag curve. So you'll get a constant series of crest and sag curves as you traverse along the road. But these curves here are unlike horizontal alignment curves, which take a radius. These curves take a K value, degree of curvature, so that when you're traveling along this road, you are able to see over the curve quite comfortably if there's any obstruction on this side. So we use a K value for a specific design speed. Okay. So in a road, you'll get an upgrade, a downgrade, upgrade and downgrade, and where these points meet, there we will have curves. When there's an upgrade, we call it a positive grade. When there's a downgrade, we call it a negative grade. And where these gradients meet, we call it a PI, point of intersection, vertical point of intersection. And where we put a curve so the vehicle can come along and traverse over here quite comfortably, we call that a beginning of vertical curve and end of vertical curve. Okay, so having that knowledge and knowing the difference between a horizontal curve and a vertical curve, and where a K value is always used on a vertical curve and a radius is always used on a horizontal curve, one will then know that what values to select from specific tables. Okay, with that being said, let's go along and look at a typical question. Here, they're telling you the PI level is that's a level above mean sea level. That's any one of these PIs here. It could be there, there, there. Now, we're not going to design the entire road. We're going to take a typical crest curve, and we're just going to design elements of that crest curve. Okay, so if we look here, they've given you the, we're going to design a sag curve, not a crest curve. In this example, it's a sag curve. So if we look down here, you've got a PI level, which means there's a PI level here. You've got the level, that is the ground, how high the ground is above sea level. You've got a PI SKD in meters, that's how far this point is from the start of the road. You've got a start level, where the road actually starts. Okay, so if you won't get a full example like this. A full example like this is for higher grades. We're looking at Transport 2A, so you'll get a typical one small example here. So given all these things, PI level, PI SKD, PI level is the level of that point above sea level. PI SKD is the distance of that point from the start of the road. Then you've got a start level, end level, a data sheet. Okay, data sheet you'll find right at the bottom here. You'll get in all your tests and exams. And for vertical alignment, we're using this table here, all the values from here for your data sheet. So you'll get a data sheet in all your tests and exams where you can extract K values. For example, our road here as given. Okay, if we go further up, we've got a design speed of 60 kilometers per hour given. So if we come to the data sheet further down, here we're looking at 60 kilometers per hour there. So if you have a crest curve, your K value will be 16. If you have a sag curve, your K value will be 16. And your minimum length of curve is 100. Means if you get a calculated value where your curve is below 100, you'll have to use 100. Okay, so those are the K values. We'll talk about it just now. Then we go up to our question again. Start SKD 310 meters, end SKD 520 meters, and your design speed is 60 kilometers per hour. So all this information here is given. Now you're going to take that information there and you're going to draw a typical diagram here so you can gain an understanding of which element in the vertical alignment you are designing. And if once one takes all these values here and draws a diagram, you'll find you designing this element of a vertical curve, which is called a sag. Okay, how do you know it's a sag? When your PI level is lower than your start level and your end level. Okay, so if we look here, PI level is 45.134. Your start level is higher than that. Your end level is higher than that. You're automatically in a sag curve. Okay, so if we look at it now and we go through this whole process, we take all that information there and we draw this diagram. You won't be given this diagram here. This you'll have to draw out to gain an understanding of what's going on. So we've got a PI level of 45.134 is our PI point, 45.134. Got a PI SKD of 430 meters. SKD of 430 meters means this point here is 430 meters away from the zero SKD. Could be far away at a point on the road. Okay. Then we have the start level at 52.156. Here's the start, 52.156. That's the level. We have an end level of 48.291. Here's your end level, 48.291. Data sheet we just spoke about now. Your start SKD is 310. There's your 310 there. And your end SKD is 520. And your design speed is 60 kilometers per hour. Okay. So first do the drawing with the given values from the above for your understanding. Draw this. That's the entry grade into the PI. That's called G1. That's the exit grade away from the PI. That's called G2. That will be a minus because it's descending, and that will be a plus because it's ascending. Okay. So if we go along, we need to calculate these. These are what you have to calculate. The entry grade, what percentage is this dropping by? Exit grade, what percentage is this increasing by? Your length of your vertical curve, that is the length of this curve. You must remember a vehicle traveling down here can't travel all the way and get stuck at this point. Therefore, at every PI, you'll have to put a curve in. The vehicle can come and comfortably maneuver on this curve and drive up. Okay? So, your length of your vertical curve, which is this length here. Your SKD for the beginning of the vertical curve, meaning what SKD will be here. You've been given the SKD of the start, SKD of the end, SKD of the PI. You need to calculate the SKD of your beginning of vertical curve. And your SKD for the end of vertical curve, this one, which is your SKD there of your end of your vertical curve. And the level at the beginning of the vertical curve, we want to find out what level this is. You've been given the levels of start, PI, and the end. You need to calculate a level here and a level at the EVC, end of vertical curve. There. Okay. So let's start with the first one, your entry grade. Your entry grade, which means it's the grade down here, coming down. What percentage is that grade? And if one looks at your entry grade calculation, it's your 52.156 minus 45.134 divided by your distance. So what we're basically saying is that level there minus that level here will give you a y, which is a distance or a height difference. So that level there, 52.156, minus this level here, 45.134, will give you a distance or a height. That height from that point to that point, so if one draws a straight line along here, if I go along and draw a straight line along here, that point from there to there is what height it is. It's that value minus that value, divided by the distance from here to there. So if I draw a straight line here and I measure a distance from here to there, so that y divided by that distance times 100 over 1 gives you your entry grade. Because it's dropping, it's a negative grade. So if we go into the calculation here, 52.156 minus 45.134 divided by 430 minus 310 times 100 over 1 gives you your downhill grade minus 5.852%, which means this grade here is coming down at minus 5.582%. Okay. Okay, 5.852%. Okay, 5.852%. Then your exit grade, meaning this grade here, going away from the PI, will be equal to that level there minus that level there, which will give you the y, divided by the x, which is a distance from here to there, which will be that SKD minus that SKD, times 100/1. Okay, 1 goes along here. Exit grade 48.291 minus 45.134 divided by the difference in the SKDs, which will give you the distance. That's the y, that's the x, times 100/1. You've got a positive grade of 3.508%. So you got a positive grade of 3.508% going up. Plus, it means you're going up. Okay. So you got the two grades. You've got that grade and you've got that grade. Okay. Which is there and there. Next, you want to calculate the length of the vertical curve. Right. Length of vertical curve has a formula. L is equal to K times A. K you get from the table. Okay, so if we go to the table, our design speed of 60 kilometers per hour is given. We are in a sag curve, so 16 is our 16. We go up. See, we've got a 16 here. Okay. Our A is G2 minus G1, grade 2 minus grade 1, which means it's actually this grade here minus that grade there. Okay, so you've got those two grades there, and if you pump all that into the formula, 16 times G2, 3.508%, minus G1. G1 is already minus 5.852. And if you run it through this calculation, you'll get a curve length of 149.76 meters. Meaning that this length of this curve here is 149.76 meters. You get from the calculation. So this answer here that we put there is calculated and then we put it down there. Okay, that curve there, that length of that curve is 149.76 meters. Right. So we've answered question 1, 2, and 3. Now we need to find the SKD of the beginning of the vertical curve. If we look at it, we want to find what SKD that is. Now we've already got a SKD for the PI. And if our curve is 149.76, we divide that by 2, okay, halfway. So if we go halfway, 149.76 divided by 2, minus it from this SKD, will give you that SKD there. Okay, because we're going backwards. Half, this is the full length of the curve, half the length of the curve back from that distance, which is SKD 430. So 430 minus half this length will give you the BVC. And 430 plus half this length will give you the SKD of the EVC. Okay, so if we come down here to the calculation and we look at it, SKD for BVC is equal to your PI SKD minus your length of vertical curve divided by 2, because you're going, why are you minusing it? Simply because your BVC is behind your PI, therefore you've got to minus it. Whereas your EVC is in front of your PI, therefore you've got to plus it. Okay. So if we come down to the calculation, which is pretty easy and straightforward, find your SKD for your BVC, beginning of vertical curve, is PI SKD minus your length of vertical curve divided by 2. 430 minus 149.76 divided by 2, that's 430 minus 74.88, gives you 355.12. So what we're saying, this SKD here is 355.12. Okay. And if we go further down into the calculation again, and we look for the SKD of the EVC, which is the PI SKD plus half the vertical curve length. So here's your PI SKD here, plus, because you're going forward, half this length of curve. So that SKD plus 149.76 divided by 2, because you're going halfway up to that point. And you should get these calculation answers here, right at the bottom. It's 430 plus 149.76 divided by 2, 430 plus 74.88 gives you 504.88. So we're saying that the SKD here on your road is 504.88. EVC SKD 504.88. Okay. Now we worked out the SKD there, we worked out the SKD there. We want to work out the level there and the level here. Okay. So that's the last two items. Item 6, level of the beginning of vertical curve and level at the end of the vertical curve. Okay. Now how do we work out levels? Okay. The fact that we have a gradient and we have a distance, we draw a straight line here, we'll get a distance. The BVC is from the PI. It's a straight line distance, so we look at a distance, we draw a straight. Looking at a straight line distance in the sense that that SKD minus that SKD will give us the distance. So the percentage grade that's dropping divided by 100 times this distance here, okay, will give us the rise in distance from here to there. Okay, so what we're saying, that percentage grade that's dropping divided by 100 times the distance from here to there, that is that SKD minus that SKD, will give you the Y. That Y value from there to there added to that level will give you that level there. Okay, so if we go down to the calculation and we look at it again in terms of your level, it's your PI level plus your grade that's dropping divided by 100 times your PI SKD minus your beginning of vertical curve SKD. So you've got your level at your PI, which is that point there, 45.134. Okay. Plus your gradient divided by 100, okay, which is the gradient that is dropping by G1. And if you look at it, we already calculated G1. Yeah, 5.852. We get to G1 divided by 100, 5.852 divided by 100 times your PI SKD minus your BVC SKD. And we run that all into the formula to find the level of your BVC, which is your beginning of your vertical curve, which is that level right there, is this answer at the bottom here. 49.516. And if we look at it, that's 49.516 and that's 52. Because it's below that, it seems to be right. Some guys get higher values here than there, means that you've made a mistake. Okay. So in the same way, we can get the level of the EVC, where we work out the exit grade percentage divided by 100 times the distance that the EVC is from the PI. Okay, will give us the Y. The Y plus that level will give us the level at the EVC. So if we go down to the calculation, and if we have a look at it, it's your PI level plus G2 divided by 100. Your PI level is 45.134, which is there, your PI level 45.134. Okay. G2 is 3.508, and we worked out the G2 right here, 3.508, which is that G2 gradient going up. Divide by 100 times your EVC SKD minus your PI SKD, which is the distance, which will give you your Y. So your Y value is that 2.67, meaning that 2.67 value there is actually the difference in height from here to there, which is that height difference there, which you add to this value here to give you that height there. Come down to your value, you get 47.761, which is your level of your EVC. And if you go to your EVC, 46.761, which is lower than that level, means you got a quick check to say that you're not higher than that level and you made a mistake. Okay, so that's your vertical curve alignment for you. That's the basics of it. This is a data sheet you will get, and this is the table you will use for your vertical curve. This will be given. You sometimes get a different design speed, so you may get an 80 design speed, then your crest curve is 33 and your sag curve is 25 for the K. Okay, so you're going to remember those as well. The full PDF format of this will be uploaded on Moodle, and the video as well to watch. Thank you, students. Over and out, Mr. Jairam.